Hi again, math friends. We're looking at 8.3 functions and equations today. And more specifically, we're looking at the linear function. A linear function has two aspects to it. The first is that it creates a straight line. The second is that because it's a straight line, it's increasing at a constant rate. Or if it's negative, it's decreasing at a constant rate. So over here on my axes, I'm going to draw an example of a linear function. To make a straight line, make sure that you have a straight edge or a ruler with you. And always at the ends of your lines, make sure you draw in arrows to show that that would go on forever if it could. Straight line, that's linear. Let's look at an example of a nonlinear function. If we have something that creates any sort of curve or does any sort of other shape, that will be nonlinear. So this, for example, is not linear because it's not a straight line. It's not increasing or decreasing at a constant rate. We're going to practice that too. This example can be found on your note sheet. We're going to find if y equals x plus 4 is a linear equation, and then we're going to graph it. To find how to graph x plus 4, we're going to substitute values in for x. We're going to substitute the values that we have in our chart here, 2, 3, and 4. Let's substitute 2 in first. 2 plus 4 is 6. Now substituting 3, 3 plus 4 is 7. Now we're going to substitute in 4. 4 plus 4 is 8. Let's see, x increases by 1, and y, 6 to 7, that's a plus 1. 7 to 8 is plus 1. So it looks like this might be linear. Let's try to graph it and see what we get. So now we're going to graph our line here. Remember our points are 2, 6, 3, 7, and 4, 8. Let's graph 2, 6 first. Over 2, up 6. And then 3, 7 will be over 3, up 7. And 4, 8 will be over 4, and up 8. Remember, we need to get our straight edge and connect those dots. This is a linear function, so you have a straight line here. Remember to draw your arrows at the ends to show that this function would go on forever in both directions. Now we're going to do an example of how to write a function from a set of data. We did this previously, but let's see if this is linear first too. 0 to 1 is plus 1, 1 to 2 is plus 1, 2 to 3 is plus 1. Your change in y, 10 to 15 is plus 5, 15 to 20 is plus 5, and 20 to 25 is plus 5 also. Since those are constant, your change in y is plus 5. Now we're going to say, well, this plus 5, remember, that means we're multiplying x by 5, and then we're doing something else. So let's see what we do here. 0 times 5 is 0. Plus what to get to 10? Plus 10 is 10. Let's see if that works for 1. 1 times 5 is 5. 5 plus 10 is 15. 2 times 5 is 10. Plus 10 is 20. Does that work for 3? 3 times 5 is 15. 15 plus 10 is 25. Since that rule worked for our data, we're going to write that as an equation. We had our number, our x value times 5, so we're going to write that as 5 times x, because x is our input. We had that plus 10. We're going to add 10. We have an expression here. This is what we worked with before. To make this into an equation, we're going to put y equals this. Because whenever we had an output y, it always equaled our 5 times x plus 10.